Our team worked with all Clad metal crafters to improve the raw material utilization in the manufacturing of their cookware. We are Çağla Düzbasan, Mary Jess Hedinger, and Matt Abbott from University of Pittsburgh, the Department of Industrial Engineering.
Clad manufactures hundreds of cookware products in their Canonsburg facility. The high quality of their products comes from their cladding technology, which bonds layers of metal together through a heated rolling process.
The manufacturing process starts when material arrives at the facility in large coils of metal. When a product order begins, the necessary layers of metal are identified and individually cut into rectangular sheets. The dimensions are specified in the bill of materials and pulled from an SAP database. The sheets are then stacked to create a pack. An example of a pack includes multiple layers such as a stainless steel exterior, aluminum, copper, aluminum, and then a stainless steel interior.
These packs are welded on one end, then rolled through the mill to a desired thickness. A robot then punches primarily circular blanks out of the pack.
The circular blanks continue on an assembly line through the plant where they are formed, finished, and polished. The scrap material, called web scraps, are stacked together and can be recycled for a salvage value.
Recent review of the formulas that determine metal sheet cut lengths for all clad products has identified opportunity for material savings in the cladding stage of the manufacturing process. The amount of excess scrap material being created is unknown, leaving an opportunity to reduce raw material usage in the cutting process. Reduction in scrap, while maintaining the quality standards of All-Clad's current process, can result in large cost savings for All-Clad.
By reducing the dimensions in the bill of materials, sheets are cut to shorter lengths, resulting in less wasted space on the web scraps. Our approach to the project is broken down into three main steps. First, we learned about the current process and its constraints, such as equipment capability and inventory complexity. This helped us develop a baseline for the current process in order to implement changes. Next, a cut length optimization tool was created to calculate the optimal dimensions for sheets of metal based on cut length formulas. These optimal lengths will be compared to the current cut lengths in the SAP bill of materials to identify opportunities for improvement. Lastly, the results will be analyzed by trialing 3 different products using the new lengths. If the runs are successful, the results will be verified in terms of weight and cost savings.
We created the cut length optimization tool in Microsoft Excel. Input data provided by All-Clad includes their bill of materials for all active products, volumes of annual product demand, raw material cost, and salvage values. We then used All-Clad's updated production formulas to calculate the optimal cut length for each sheet of metal in each product. We compared these cut lengths to the cut length in the bill of materials. Any shortening of cut lengths were converted to potential net savings per year per product. A detailed methodology including formulas, units, and instructions for adding new products to the Excel database is included.
All-Clad uses formulas to determine appropriate cut lengths for each of the sheets needed to make a product. The manufacturing floor uses the bill of materials to identify the cut lengths for a product. We look to quantify the discrepancies in cut length between the formulas and bill of material by evaluating the changes in length, weight, and cost savings. Using the results in our cut length optimization tool, we identified products with opportunities for dimensional reduction, but it was important to test these results on a small scale before large-scale implementation. We consulted with All-Clad to identify products that would be good to test based on the manufacturing schedule, annual product demand, and opportunity for cost savings.
3 different products were selected and tested with proposed dimensions. 10 packs of each product with updated cut lengths were added to existing production runs. The parameters of the process remained constant for all packs so that the outputs could be compared. 3 packs with the current lengths and 3 packs with the updated length were saved from each of the products for evaluation.
Each product we tested had cut lengths reduced by at least a quarter inch. The trials ran successfully and did not result in missed punches. The difference in wasted space between the current packs and the new proposed packs is clearly visible. The packs from testing were weighed in order to verify the changes. Testing resulted in a reduction of weight for all products using the updated cut lengths. Due to the lack of precision of the scale, we observed a slightly different change in the weight than what our model predicted. Even with the slight error in the result, the trial proved that the reduced dimensions produced the same quality products.
With the results of the test verified, we created an engineering change request to update the SAP system at All-Clad with the new cut lengths. Based on the 2016 demand data, the implementation of changes for all 3 of these products will lead to an annual savings of nearly $49,000 and 10,000 pounds of raw material. If all products test successfully and changes are made to the cut lengths in SAP, Clad could reduce raw material costs by over $430,000 annually.
Moving forward, Allclad will continue testing its products in two ways. They will test the remaining active products using change dimensions on a small scale, similar to the testing performed in this project. They will also test products with successful small-scale results on an entire product run, which could be hundreds of products. Testing all proposed dimensional changes could take a long time because of the number of active products, but Allclad expects to test each of them based on the success of the 3 trials completed during the duration of this project.
We owe the success of this project to our sponsors and professors and wish the best of luck to all Clad in the future.